Hello guys, I'm back with the example we left in the last class. So this was the example. I hope and expect you would have gone this word problem at your own, but now we are coming to its solution part. So we are dividing this problem into two parts. First the given information and next what is being asked from us. So let's first sort out or chalk out the pieces of the information we are given. If you start from here, the very first information we are given is the production price of the radio, which is $2 per month. And the next is the current selling price. So this is current selling price which keeps changing, or it is proposed to be changed, increased, right? So this is the base price, $5 per radio. Currently, when the price is 5, the number of radios sold are 4,000, right? And now the price is increased. When price is increased by each $1, right? Now this is important. So when you just increase each $1, 400 fewer radios are sold. So the quantity demanded in the market is decreased by 400. This means for each dollar increase, we are supposed to sell 400 less units in the market. So these are the information given, and next we are asked to model the function, develop the function of the profit which should depend upon the price. So remember that depending part, but we have to just form the function of the profit, right? And remember from your basic economics, so the profit is equal to revenue minus cost. Okay, so we need to find formulas or functions of these two, and then subtracting these two will give us the profit, and then we will decide or see or check if it depends upon the price or not. So during the process of constructing these two functions, if we make sure the revenue function and cost function depend upon the price, then automatically profit will depend upon the price. So it will automatically depend upon the price. So we will make sure the revenue and cost functions depend upon the price. Okay? So in order to have these two functions, let's start defining the variables. The very first variable is a variable for the price, which is, let's say, P, and then we have a variable N. It denotes the number of radios sold when price is P. Now N is equal to 400, it's a fixed value, when P is 5. This is given as information, and it is also given if you increase the price by 1, it means if you just make price 6, your number N will be 3600 because it will be decreased by 400. And if you increase another dollar from 6 to 7, you will decrease further 400, means 400 times 2 will be decreased from the 4000 units which were sold at this price 5. So this will be 32. And similarly, by every increase of $1, our demand will be decreased by $400. So this can be rewritten into this formula. So N is equal to, as a function of P, it's 4000 minus 400 times P minus 5. So when P is 6, this will be 1. When P is 7, this bracket term will be 2. And when P is 8, this bracket term will be 3, and subsequently this 1, 2, 3 will be multiplied by 400 and subtracted from this original price. Okay? As a particular example, just let's take when price is 7. This means increase of $2. It means this situation. Okay, and this situation means how many amount we are supposed to reduce, how many number of radios, 800, 400 times 2. So this minus shows it will be subtracted. This is 400, Now P is 7, 7 minus 5, this will end up as 2, 2 times 400 is 800, so we will subtract 800 from this 4000 and this number n will be this amount. So this is general formula, and now from this red formula we just take 400 common bracket, we will left with 10 here instead of this 4000 because 400 is common, minus is there, this 400 is common, we will have 1 here, bracket p minus 5 will be here. Now 10 minus p minus minus plus 5, so plus 5 and plus 10 is 15 minus p, so we will have this nice formula for number of radios sold when price is p. Price is p, which is already written here, right? So price is p. Now just plug in when price is 5, when price is 5, so 15 minus 5 is 10, 10 times 400 we have 4000, that's it. Okay, so this n is the number denoted. Remember this formula, we need this one, profit is equal to revenue minus cost. So we have to first find revenue and cost. If you, okay, let me explain. If so revenue, so cost in the next slide it is already mentioned, but let me explain. So revenue is just n times p, the number of units sold time price, minus, and this cost is variable cost plus fixed cost. In this case of radio, we only have a fixed, variable cost. So fixed cost is just 0. This is 0, and the variable cost is, this is just 2 per radio, if you remember. Okay, so it's just $2 per radio. We will use this formula in the next slide. Revenue is n times p minus cost is this one. Remember this formula for n, it's a 400 times 15 minus p in terms of p. P is already here, price. So this is 2 times n, total cost. I mean per radio cost is 2, but for many its cost is 2 n times 2 times n. Okay, so p denotes the profit. Third thing, it is equal to revenue minus cost. RP denotes revenue, let's say. CP denotes cost. We need this function as a function of price. Independent variable should be price. Now the revenue is equal to price times quantity sold, means P times N, Rn times P, as I mentioned, and N is was already defined in the previous slide, which is 400 minus this one. Okay, so let me highlight this. No, this is the highlighter. This is N, and this is formula for N from the previous slide. Okay, so this is revenue, P times 400 bracket 15 minus P. Again cost, which is variable cost plus fixed cost. Fixed cost is 0, variable cost is 2 for each radio, and if we have n number of radios and n is equal to 400, kind of this, so yeah, so this is CP. Okay, so we only need to focus on now these two expressions, this one and this one. We have to subtract cost from this one, so this will be